Okay, so we're going to start out. We are not going to do this first problem, so just cross it off. We're just going to skip right ahead to the verifying trig identities. So this is very similar to what we did last time. The main difference is you know where you're starting and you know where you're ending. Okay, so this is your start, this is your end. Now you don't necessarily have to start on the left side and go to the right side, but usually you want to start with your more complicated side. So complicated really means like if you're adding or subtracting two things, like this left side, that's more complicated than multiplying two things together for what we're going to do. So you're going to start by rewriting your more complicated side. So in this case, secant of theta minus cosine of theta. Okay, so we're going to kind of ignore the right side for right now, but that's what we're going to try to get to in the end. Okay, so that's when you're thinking about your word ladder, here's your first word, this is our last word, and we're trying to go one step at a time to get to that last one. So one technique that we used last time that we'll use here is by rewriting each trig function in terms of just sine or cosine. So secant of theta is 1 over cosine of theta. And then cosine of theta we can just leave alone, or if you want, you can write it as cosine of theta over 1. So we want to try to simplify that in some way. So we have two separate fractions, subtracting them. So we really need to find a common denominator. And so that denominator is going to be cosine of theta. So on the second fraction here, we're going to multiply it by cosine of theta over cosine of theta. That way it has a cosine of theta in the denominator. So what we'll have next, if we combine those, is 1 minus cosine squared theta, all divided by cosine of theta. Okay, so I just put those two fractions together. This one was cosine squared over cosine, and then we just subtracted them. Now hopefully at this point the bells are going off in your head. 1 minus cosine squared theta is a very important identity. We remember, I'm just going to make a little note over here, sine squared theta plus cosine squared theta is equal to 1. That was our first Pythagorean identity. So to make it look more like what we have, we can subtract cosine squared from both sides, and we would get sine squared theta equals 1 minus cosine squared theta. So what that means is we can take our numerator here, and instead of writing 1 minus cosine squared theta, we can write it as sine squared theta. So it's sine squared theta all over cosine theta. So now we're a little less complicated. Now let's look back up at what we're trying to get to. We're trying to get sine of theta times tangent theta. If you look at our expression right now, we do have a sine of theta, but we have sine of theta squared. So we're going to separate that sine to sine of theta, and we're going to multiply by what would be left. We would still have a sine of theta in the numerator and a cosine in the denominator. Okay, so we have that sine of theta by itself. We still have a times sine over cosine. And then you should think about what sine over cosine is, and you remember that it's tangent. And now you notice we got to our ending point, sine of theta times tangent of theta. So we're done. So these problems are all about the process. You know where you start, you know where you end, you just have to get there. And so in some ways it's like the geometry problems when you did two-column proofs. You know what's given, you know what you're trying to prove, you just have to show the steps. So you really have to make sure your steps are correct in the right order. You're showing your thought process. You also need to make sure really that all your equal signs line up. So you're just starting at one side and working your way to the other. If you need to, you can work backwards, but you shouldn't really be using both sides at once. Okay, let's move on to the next problem. So we have cosine of theta over sine of theta times cotangent theta equals secant theta cosine theta. So in this case, the more complicated side is the left side. So we're going to start there. So rewrite that. So just rewrite it exactly how it is at first. And then we're going to start trying to simplify that in some ways. And sometimes when you're trying to start simplifying, it gets a little bit more complicated at first, but then something should work out, it should cancel or something like that. So we have cosine theta on top. Sine of theta we're going to leave alone as well. Cotangent of theta we can replace. You could either do 1 over tangent theta, or you could do cosine over sine. In this case, we'll do cosine over sine because we already see other cosines and sines in our problem. Okay, so that's what we have. Now, before you move on to the next step, let's look and see, is there anything that you can do to simplify this? So hopefully you notice that there's a sine of theta and a sine of theta that will cancel out. So that just leaves us with a cosine of theta in the numerator and a cosine of theta in the denominator. Now you might be tempted to cancel those out and you would just get 1, but you really have to keep in mind what you're trying to get to. We're trying to get to secant of theta times cosine of theta. So we want to take this expression here and make it look like secant of theta cosine theta. So we're going to separate this into 2 parts. We know our second part has to be a cosine of theta. So that means our first part, if we took the cosine of theta from the top, our first part is 1 over cosine theta. So those two together would give us cosine over cosine. But we also know that 1 over cosine is secant theta, and then times cosine theta. And so we end up getting the identity that we wanted. If you had gotten stuck here, you could start down at secant of theta cosine theta and work your way backwards, knowing that secant is 1 over cosine and then times cosine, and then notice that that's equal to cosine over cosine. But you do have to keep in mind all of your equations should line up. So all of your equal signs should line up right there when you're showing your work.